Okay, the logarithm equations worksheet that you were given for homework. I've got 6 of the questions lined up here, ready to go to show you full-on solutions for them. Um, I'm not gonna do a lot of middle steps in the interest of saving some time, but here we go. If you're still having difficulty with some of the questions, well, let me know and we'll try and work it out. So I'm going to give probably the solutions for the way that I would do these. There are or might be different ways of doing this. Um, so here we go. For this one, when I look at this, the easiest thing for me to do is to divide both sides by 2, and it simplifies to this, so I can get rid of the 2 right away. Some of you might decide that you want to use the reverse of the power rule for logs and end up squaring this thing. You can do that as well, that's fine. Now that I've got this in terms of one logarithm, the easiest way for me to be able to get at that negative 2r is to convert this to exponential form. So 7 to the power 0, remember our little our circle trick, 7 to the power 0 is equal to negative 2r. And so anything to the power of 0 is 1, so negative 2r is equal to 1. And isolate, and r is equal to negative 1/2. Done. Next one. The nice thing about this is that both sides are of the logarithm of something. So for me, when I look at this and I see the log of something is equal to the log of something, well, in my mind, the way I understand that is that if it's the log of something equals the log of another something, those two somethings have to equal each other. So my plan of attack for this right away is to say, well, okay, then I know that v squared plus 35 has to be equal to negative 12v minus 1. This is a grade 10 quadratic. So v squared plus 35 minus 12v, so this becomes plus 12v. Minus 35 plus 1 gives me 36 and equals 0. This factors to v plus 6 all squared, right? Therefore, v is equal to negative 6. Done. If you're a little bit, if that was a little bit too fast for you in terms of middle steps, well, just come and find me and we can talk about it. Next one, similar type question, right? The log of something is equal to the log of another something. Base of 9, base of 9, I'm allowed to simplify and make it so that this box equals this box. So this is a very similar question. So it's negative 11x plus 2 is equal to x squared plus 30. Simplifying that, I'm going to put everything onto the right side here. So it's x squared plus 11x plus 28. And that goes and factors into x plus 7 times x plus 4. That equals 0. Therefore, x is equal to negative 7, or x is equal to negative 4. Right? Now, we're not talking about restrictions, but if we were talking about restrictions, we might be in a little bit of trouble depending on whether or not both of those two numbers would satisfy the original equation. Luckily, they do. So we're not in any restriction type trouble. Next one. This one. Now, we can't do what we did before and simply go, oh, base of 10, base of 10. So this is a no-no. So I'm going to highlight it bad. Don't do this. Make this simplify so that x minus 2 is equal to 10 to the power of 1. That is not how your log laws work. You are not allowed to do that. Okay? Actually, I'm just going to get rid of that altogether. So you're not allowed to do that. Okay, that's not how your logs work. Logs have to be all on one log on one side and all on one log on the other side for you to be able to simplify like that. However, we do have a log law that says we can simplify and group this to log of x over 2. That's one of your log laws, the quotient law. And that equals 1. Now I can go x over 2 is equal to 10 to the power 1. And x is equal to 20. Finished. This one, same deal, right? I can't just drop the logs and get rid of them and say x plus 1 minus x equals 29. I'm not allowed to do that. So, what am I allowed to do? I'm allowed to use my log laws to simplify this side. This side I can't really do anything with. But this side, the left side, I can simplify to log 6 of x plus 1 over x is equal to log base 6 of 29. Okay, now I've got this side on one log, this side on one log. Now I can equate the two arguments, the x plus 1 over x and the 29. X plus 1 over x is equal to 29. This is just like the example I did where I showed you the highlighter stuff. Now I've got x plus 1 equals 29x. So 1 is equal to 28x, right? Just subtracting, put the x onto this side. So x is equal to 1 over 28, and I'm done. Last one. Same idea, right? Not on a single logarithm, so I can't just drop the logs. They don't cancel. There's no such thing as canceling a log. So I can simplify. Now, instead of a minus sign like I had here, I've got a minus sign like I've got here, I've actually got a plus sign this time. Okay, so my log law is slightly different. So log of 5. Now instead of dividing here, I multiply. So this becomes 6 times 2x squared to give me a 12x squared. And that is equal to log base 5 of 48. Right? Get rid of those. Well, not get rid of, but equate this argument to this argument. And now I'm off to the races. And I'm done. So those are 6 quick examples from your homework of how to do them. Okay, so moral of the story: if you're really good with your logarithm laws, then you can breeze through these problems pretty quickly because there's a way they're cooked up nicely so that they simplify in some sort of a simple fashion. Okay, so hopefully that helps. If not, that's a sign that you need to get some clarification. So seek math help. Goodbye.